Swayam Prabha. Digital India. Educated India.
Welcome to the next session on commodity derivatives and risk management. If you recall, we were discussing about minimum variance hedge ratio, and we calculated minimum variance hedge ratio using the formula method as well as the regression method for three commodities, that is your black paper, isabgol seeds and raw jute, which these three contracts are traded at national multi-commodity exchanges, traded and listed at national multi-commodity exchanges. Now let's, if I recall, I posed a question to each of you that can the minimum variance ratio be greater than 1? So what is your question to, what is your answer to my question? Okay, so had it been a regular class, I would have come to know your answer. So this is the negative side of any asynchronous communication. So this is something which probably as a teacher none of us enjoy, but given the constraint, I'm trying to make use of the most of it. So I don't know what is your answer. So now I'll start this session by giving answer to your question, to the question I posed. But before I go to discussing whether minimum variance hedge ratio can be greater than 1 or not, let's summarize what we had found out for the three commodity contracts listed at NMC. So let's focus on the details which is given on the screen. So if you recall, black paper had a minimum variance of hedge ratio of 0.35, isabgol seed had 0.999 or equivalent to 1, raw jute has 0.21, and a coefficient of determination respectively given. Now again I'll pose another interesting question to you. Is minimum variance hedge ratio calculated by using the this formula method or the regression method is really the minimum variance hedge ratio? Can there be any other combination of spot and futures combination which will result in a lesser amount of portfolio risk? So to do to test that or do a sensitivity test, I took just random combination of portfolio, both spot as well as a futures combination. So this particular second panel of this second table in this slide indicates the various combination of hedge ratio and portfolio risk for the black paper. So if you recall, the hedge ratio had minimum variance hedge ratio is 0.35, and the portfolio risk for the paper, that is the standard deviation of portfolio return, daily return is 467.8. So let me take you to the link file. So let me take you. So let's go to this test. This is the second worksheet of the Excel file. This particular table shows when the spot price is this, future price is this. So when you have a delta 0.35, please focus on the column G. When the hedge ratio is 0.35, what is going to be my portfolio risk? So portfolio risk is 467.8. Similarly, when the hedge ratio is 0.5 as given in column H, the portfolio risk is coming to 489. I just took another random number. So portfolio minimum variance hedge ratio is 0.2. That means for every 1 unit long on asset, the producer is entering into 0.2 units of futures contract. With this, the portfolio risk is 489.7, 0.80 as hedge ratio, portfolio risk is 635.4, and 1-to-1 hedge ratio, which is our naive hedge ratio, that is 1 unit long on asset will be hedged by 1 unit of under a futures contract. So you have a portfolio risk is coming to 778.1. So going back to our slide, so if you see this particular PPT, this particular table, second panel, shows the various hedge ratio combination with respect to the portfolio risk for black paper, and if you can see this, with 0.35 as a hedge ratio, the portfolio risk is lowest. In fact, with the Excel file which is available to you, you can try out other combination of hedge ratio and check whether really minimum variance hedge ratio holds true with 0.35. Portfolio risk is the lowest with hedge ratio of 0.35 or any other combination. Now going to my question on can hedge ratio be greater than 1? The answer to this question is yes, hedge ratio can be greater than 1. So why hedge ratio can be greater than 1? Let's discuss how do we define our hedge ratio using the formula method. If you remember, hedge ratio is nothing but the correlationship between delta S delta F and sigma delta S by sigma delta F. So this is the correlation between price change, and sigma is the standard deviation of change in spot price, and this is the standard deviation of change in futures price. Let's say correlation between spot price and future price can be maximum, it can go to 1. So this factor can be 1, and if both are standard deviation is same, then you can have this ratio as 1. So 1:1 will be 1. Now the next question is when it can be greater than 1. It can be greater than 1 when you have the standard deviation of delta S is significantly higher than the standard deviation of delta F. That is, future spot price has a greater volatility with respect to the futures price. So this is the situation where you can have minimum variance hedge ratio can be greater than 1. So I have again taken a hypothetical situation. So let me go back to black paper May 2016 data. So I have the same data, however I have done some modification, random modification to the futures price and the spot price, without doing any change to the price prevailing on the contract squaring of date. So this part, beginning price combination and the last price combination, spot futures price combination, I have kept unchanged, and by doing changing some of the values, what I have found out is that if you see, the correlation between spot futures have come down to 0.20 from the earlier correlation of 0.53, and standard deviation of delta futures is 958, standard deviation of delta spot is 4896. So just to give you an example, the standard deviation of delta spot is almost 5 times the standard deviation of delta futures. So taking into consideration all these factors, you can have minimum variance hedge ratio as 1.06. So this gives an this answers my question that yes, there could be situation where you have minimum variance hedge ratio as greater than 1, and this could be with respect to a higher volatility in the spot market vis-a-vis the futures volatility. Now So as I said, this ratio will be higher if variance of the spot market is higher than the future market, and this normally happens in case of a cross hedge. So if a particular commodity producer is hedging its price risk using the similar kind of or same commodity, let's say soybean oil producer is hedging its price risk by entering into futures contract on soya oil, the chances that the hedge ratio going to be more than 1 is very limited. However, if you recall, in the last session, we had discussed that many a times commodity futures contract, the number of commodity futures contract available for trading is limited, and all commodities futures contract on all types of underlyings are not available. So many a times commodity producers and consumers enter into a cross hedge, that is the commodity which is very similarly behaving like their underlying exposure but not the same commodity. So it could be situation in case of a cross hedge, there will be a possibility of hedge ratio, minimum variance hedge ratio to be greater than 1. Otherwise, in normal situation, we know the cost of carry model will ensure that the spot and futures price move in some similar fashion. So over a sufficiently long period of time, if we take to calculate the minimum variance hedge ratio, so the likelihood of minimum variance hedge ratio beyond 1, and if the underlying asset and the underlying of the futures contract is same, there is very little likelihood of minimum variance hedge ratio to be greater than 1. Now let's go to the next question. Can this ratio be negative? So I am not going to answer this question at this point of time. This is a food for thought for each of you. Find out or think intuitively whether this ratio can be negative. So if negative, then what would be the strategy? How a hedger will be able to hedge its risk using a negative hedge ratio, if at all negative hedge ratio is possible. Now if you recall, We had discussed about commodity options in some earlier part of the lecture. Though commodity option contracts are not traded, today I will be spending some very briefly some time on how do we go about value commodity options, because substantial amount of time we have spent on valuing futures contract and pricing and valuing futures contract. And today we will be spending not much of in greater detail, but some basic aspect of how commodity options can be valued. And I'll just take you through the basic concepts of commodity option. If you recall, the exchange listed commodity options do not have the commodity as the underlying, but they have commodity futures as the underlying. And the long call option position holder, whenever he exercises, he gets to take a long position in an underlying commodity futures contract. Similarly, whenever whenever a long put option position holder exercises its option, and that party takes a short futures position. So let me repeat: a long call option holder, when it exercises its option, he takes a position, long futures position on the underlying at a strike price, and a long put position holder, when he exercises the option, he takes the short futures position at the exercise price. Now let's focus on whatever is mentioned here. Let me just again read out. Long call option: the purchase of a call option gives the holder the right to long futures position at the strike price. And purchase of a call option, that is the right to buy a futures position. Please note here, when we are talking about purchasing a call option, it gives the buyer the right to buy a futures contract at a later date. In a regular options, you have the buyer has the right to buy the underlying, but in case of a commodity futures, the long call position holder or the buyer has the right to buy the futures contract, and at what price? At the exercise price. And by taking a long call option, it protects the buyer of the option against the rising prices. So if prices rise, the buyer can exercise its option, takes a long position in the long futures position in the underlying, and if the underlying price increases and commensurately the future price also increases, the buyers of the long futures position stand to gain, because he has bought a futures at a lesser price, and subsequently the futures price has gone up, and he will be able to make profit from the long futures position. Similarly, long put option gives the buyer the right to sell the futures contract at a later time. So the long put position takes a short futures position when he exercises his option, and when he will exercise his option, he will be exercising his option when the underlying price is going down, and commensurately the futures price has gone down. So now when he has a short futures position and the future price goes down, he will be able to make profit, because the short futures position holder gains from the futures contract only when the future price goes down. So he had agreed to sell at a higher price, and he will be able to square up or buy the underlying contract at a much lesser price, thus gaining from the decline in the futures price. So this is in a nutshell what is the difference between a regular option contract on financial asset and a option contract for commodities which have a futures as underlying. Now I am sure all of you must be knowing how Black-Scholes option pricing model is used to calculate regular options, and exactly in place of a Black-Scholes option pricing model we do some amount of modifications to value the commodity options having a futures as underlying. So in the year Black 1976, Fisher Black in the year 1976 developed a model for pricing the commodity options. If you recall your Black-Scholes option pricing model, so let me just briefly write Black-Scholes option pricing model. So you have, if you recall, the call premium is nothing but your S0 ND1 area under normal distribution minus K into e to the power minus RT into ND2. So I am not going into the explanation of ND1, ND2. I am sure all of you must have done these concepts in your regular derivatives subject. If you have not done, then I would advise all of you to read any standard book on option valuation, that is John C. Hall and on the Sankarsan Basu, which is a very seminal book on derivatives, or any other book or any other website which you feel comfortable. So this explanation of ND1 and explanation of ND2 is beyond the scope of this particular lecture series. So C is S0, so S0 is your spot price, K is your exercise price, and R is your continuously compounded risk free rate, T is your time to maturity. Similarly, P is your K into e to the power minus RT n minus D2 by minus S0 into n minus D1. So C is your call premium, P is your put premium, and this is the premium which is paid by the long call position holder, and a put premium which is given by the long put position holder to the counterparties, that is the short call position holder as well as the short put position holder respectively. Now when the underlying is not S0 but it is a futures contract which is going to mature at a certain point of time in future, we do some adjustment to the above formula, and in place of S0 we use the futures price. However, we are pricing the call and put on today's date, but this futures contract is going to mature at a later point of time. So to do this adjustment, this Black 1976 formula, so if you see this, you have F0 is your F0T is the future price prevailing today, and K is your exercise price, and you have e to the power RT minus RT. R is your risk free rate, T is time to maturity. So this is your this is the formula for the call premium. Accordingly, put premium is governed by the second equation, that is e to the power minus RT into k n minus d2 minus f0 into n minus d1. So if you recall, in place of your this is just the same formula with minor adjustment, because of we are not using in the underlying for valuing the call or put option, but we are using the spot the futures price prevailing at that point of time as the underlying. So accordingly, your d1 and d2 has been defined. So ln f0 by k plus sigma square t by 2. So this formula can be used for valuation of European options, commodities options with commodity futures as underlying. As I said, because commodity options are yet to be started in Indian exchanges, we are not going much detail into the valuation, valuation or actual valuation of this commodity option contracts, taking some real life data. Now I will be summarizing what we have discussed in the last couple of sessions. So let me pose these questions to all of you, so that you will be able to understand what should be the key takeaway from last 4 to 5 lecture sessions. So what are the key questions or key takeaways? What is the difference between spot price determination process for financial underlying over commodity underlying? So we have futures and options on financial underlying like stocks, bonds and indices like Sensex and Nifty, and we also have futures on single stock like stocks of ITC, L&T, etc. And we have commodity futures. So what is the difference between the spot price determination process for the financial underlying over commodity underlying? Well, if there is a difference, does it have any bearing on the calculation of the future price? So that is the first key takeaway. The second question is, or second key question is, what is the cost of carry model with no arbitrage assumption? And all of you know that futures price, be it financial futures or commodity futures, are priced based on the cost of carry model with no arbitrage assumption. Similarly, if this cost of carry model does not hold true, then traders can, or arbitrageurs can, take cash and carry and reverse cash and carry arbitrage positions. So how exactly it is done, that should be also clear. What is the difference between contango and backwardation, and why contango and backwardation happen? What is the logic behind contango and backwardation? We also spend considerable amount of time understanding what is a basis risk, and what is basis and what is basis risk, and why basis risk is applicable to futures contract and not for forward contract. So this is something also which you must get a clarity on, that futures contract have basis risk while forward contracts do not have basis risk. We also spent some time understanding what is a cross hedge, and we also last couple of sessions we have discussed what is a hedge ratio, what is a naive or 1-to-1 hedge ratio, what is minimum variance hedge ratio, and what is hedge effectiveness measured by the coefficient of determination. I also had asked this question already. We have already answered this question: can hedge ratio be greater than 1? And my second question, what about negative hedge ratio, I am yet to discuss. However, I am leaving it to you all to read and get answer to this question, whether hedge ratio can be negative. If so, then what would be the trader strategy? And finally, we very briefly discussed how commodity options with futures as underlying can be priced, both call and put option. And by this session, you should be also get some clarity on how the commodity options can be priced in a different manner as compared to the regular financial options. So thank you all of you. Looking forward to interacting with you all in the next session, and I hope these concepts you'll spend some time to assimilate and understand these concepts in detailed manner. Thank you all of you.